things happen. So when those models come face to face with them, they're more likely to fail and offer a incorrect prediction. The DFDC data set was used for the deepfake detection challenge by Meta, which called a lot of developers to create deepfake detection models. And in the evaluation process, they were tested against a black box data set, a completely secret data set, and the top 6 participants, after being tested, dropped to as low as 37th place because they were presented with these new medias in their black box data set, which shows the effect of ill-prepared models when used in the real world. So for my experiment, I used FaceSwap, a deepfake creation application, which creates a FaceSwap deepfake, which takes one person and swaps another person's face, keeping the original person's facial expressions and movements. We wanted to test how dataset size and variability affects deepfake creation, and also how the model would perform on people of different demographics. In the FaceSwap model, your dataset is given by the user. I provided the images, but face extraction is a crucial step in the process, which uses outside models for face detection and face characteristics, landmarks when they put the faces on top of each other to match, which is where inherent bias may be introduced. And I wanted to test that. So I created these 2 deepfakes, one of Caucasian males, Hugh Jackman and Ryan Reynolds, and the other of African American females, Lizzo and SZA. I input videos of each person into the model and extracted images on their video frames to create my data set, which you can see here. For Hugh and Ryan's deepfake, Hugh Jackman was the target face A, and Ryan Reynolds was the swapped or generated face B. And for Lizzo and SZA, Lizzo was face A and SZA was face B. I maintained the same amount of images for each of the face A's at 1,009 images, and each of the face B's at approximately 1,446 or 42 images. And then I created the augmented training data set by mirroring the images and doubling the data set, also providing more variability for the model. Hopefully, when a face A turns one direction that maybe face B didn't turn, I would show the model another side of the face to be able to generate better and fill in those blanks that may not have been provided. So in total, I created 4 deepfakes, 2 with the original data set and 2 with the augmented data set. I trained each model for a little over 500,000 iterations, checking the average face loss at 100,000 and the 500,000 mark. Face loss is a metric that quantifies the difference between the swapped face and target face. So a higher face loss meant there was still a large discrepancy between the 2 faces, meaning a unrealistic deepfake, and the lower the face loss meant the model was doing a better job at blending the faces, creating a more realistic deepfake. So to compare the results, comparison of the Lizzo and SZA face swap between the original and augmented data sets at 100,000 iterations and 500,000 iterations. So the difference here was slight. For face A is the red line and face B is the blue lines. So for face A, the difference was slight, but there was a consistent difference for face B, meaning the model did a better job at blending face B for the augmented data, for the deepfake trained by the augmented data set. Next, for Hugh Jackman and Ryan Reynolds deepfake, These had a less of a difference, closer performance. And for the results, comparing how the model performed on the different demographics was much more of a discrepancy or a difference. For the original data set at 100,000 iterations, this first graph, Hugh Jackman performed, had a lower face loss than Lizzo at the 100,000 iterations by approximately a face loss of 5 thousandths, and Ryan Reynolds had a lower face loss than SZA by approximately 25 ten thousandths. And it performed the same for the augmented data set. The face loss for the Caucasian males was consistently less than the face loss for the African American females. And here it is for at 500,000 iterations. The difference between face A for the deepfake trained with the original data set, Hugh Jackman had a lower face loss by a face loss of 3 thousandths, and face B had a lower face loss by 12 ten thousandths. For the augmented data set, face A, Hugh Jackman had a lower face loss by 33 ten thousandths, and Ryan Reynolds had a lower face loss than SZA by 9 thousandths. So, in conclusion, my findings, I found that with the same data set size, same number of images trained by the same model for the same iterations, the model did a better job at blending the faces of Caucasian males than it did African American females. And though the difference with the mirroring was slight, it did benefit or help the model with the African American females, which it was already performing poorer at, so it helped bridge that gap a little bit. For my future works, like I said, with the data sets, I would get the data sets and fully annotate them for all the attributes and characteristics that can affect these models to help developers know what they're actually training their models with, what biases and gaps they're leaving open. And I would like to thank the National Science Foundation grant and Florida A&M Title III undergraduate research project for making my research possible. Thank you. Any questions? All right, thank you. So future works is to retrieve like the popular data sets that I found and use other models to annotate them, so like gender classification models fully understand what genders, specifically know what these models are made up of, so we know exactly and precisely what we're training the models with, what information and what characteristics and attributes they're learning, so we can also know what gaps they may have and what biases they may are being trained by. So fully annotate the data sets that are available and test, again, data set size, variability on demographics, characteristics on models that are out there, and see how their accuracy rates change, because they have been proven to change when put up against different testing data sets.
So I was trying to think of a way to phrase my question, but I thought some of the models you had mentioned earlier were trained on images and videos. all reality, video is just a collection of
Absolutely.
large images. But for the models that are trained on video, was it done like a whole of the video, or was it broken down frame by frame, trained on that large set of images?
Yeah, from what I've seen, they are broken down frame by frame to analyze each images for discrepancies. There are different types of discrepancies that some models look at for like their methodology for how they determine.
Do you feel videos would be a better training source for the AI, or just images in general? Because I feel like for videos, obviously, typically the videos are just of a specific thing, so it might really be a hone down on that demographic. Would you believe that would perform better than just a wide collection of images?
Yeah.
Question, apologies. Just, what do you feel would be a better training ground for videos?
So, what would be a better training platform? Models that are used to on videos, or trained by videos, or trained by images. Because most of the models I've seen do break down their videos into images, I do think they are pretty similar. So yeah, the main thing I do think is the hindrance are knowing what attributes and characteristics are present in whatever images or videos they are being trained by.
Another thing I keep in mind as you are going through presentation was obviously as the time develops, people are using AI to develop images because of whatnot. What's the potential there for training sources becoming saturated with AI images and the rest of that using to train other AI?
Well, yeah, it would be that they're trained in-house first, so they're trained on data sets that are labeled as this is authentic data and this is faked data. So that way the model already learns that difference. So when it goes out into the wild, it's already pre-trained. It's already, it's not getting training. It should already be trained before it goes out to test. But a hindrance is that the deepfakes and fake media out there in the world now are much higher quality than what the models today have been trained by. So they do get by.
For your 4 samples, 4 persons, did they have any nuances that kind of came out in the images, like pictures or something that really kind of caused problems with any of the random generations?
Well, yes, of course. So they had different videos. So there were different movements, hand movements. Some people had like their hand cover their face, which caused the face swap to like glitch and become unrealistic in those frames. So the variables I focused on were keeping the image numbers the same, and then also creating the augmented data set with the mirroring. I hope that answered your question.
I was thinking, they've got some real obvious scar that you mirrored it with twice as fast.
Oh, right. It would guess so.
They're pretty symmetrical faces. They don't have any unique. As you're going forward, you got to look at variation and models. I think it's cool that you're looking at races and bias stuff like that. Given the factor alone, trying to be somebody else that may have something like glitch more noticeable, take more images than trying to versus 1,000 doesn't seem like a lot. Superstars and kind of stuff on the screen. Trying to pull out, if you're doing a deepfake overseas,
Yes. Yeah, so absolutely. One of the things needed for it to properly train this model was a certain amount of images. You needed at least, what was it? You needed thousands of images, I want to say. So you needed thousands of images to be able to properly train the model. So anything too little wouldn't give the model enough to learn from. And I believe that you were saying that with the mirroring, downfall could be if someone has a scar or something on one side of their face, mirroring it wouldn't create that exact replica because you would be creating a fake illusion of something on the other side of the face that's not there. Yeah. All right, thank you.